Hello, I'm Praveena from RV College of Engineering. So today I would like to talk about applications of linked list. So before going to applications of linked list, I'll just tell you what is linked list. So linked list is a non-sequential collection of data items. It is a dynamic data structure where every data item in a list there is an associated pointer which will give the memory location of the next data item in the linked list. So the data items in the linked list are not in consecutive memory locations. They may be anywhere, but the accessing of these data items is easier as each data item contains the address of the next data item. So that is a linked list. And there are advantages and disadvantages of linked list. So the important or the very important, most important advantages, because it's dynamic. They can grow or shrink during the execution of the program. And it has efficient memory utilization, etc. And disadvantages, additional space is required because you have to store the address of each and every node. So, and there are different types of linked list, such as single linked list, double linked list, circular linked list, circular double linked list, etc. So we are not going to concentrate on those things. I'll start with applications of a linked list. So there are many applications of linked list. Few of them are just listed here. The first one is used to represent, manipulate a polynomial. As we know, polynomials are expressions containing terms with non-zero coefficient and exponents. Example: P of x is equal to a0 into x raised to n plus a1 x raised to n minus 1 up to the last term a raised to n. So linked lists are used to represent the polynomials. We can also do addition on polynomials and many other operations. We can also represent very large numbers and perform some operations on these large numbers such as addition, multiplication, division. Linked lists are also used to implement stack, queue, trees, and graphs. We can also represent sparse matrix using a linked list, and we can construct a symbol table and compiler using linked list. So first one is a polynomial. So what is a polynomial? It is of the form summation I is equal to 0 up to n ci x raised to I, where ci is the coefficient of the ith term and n is the degree of the polynomial. So some of the examples are listed here. So like 5x squared plus 3x plus 1, etc. And it is always not necessary to write the terms of the polynomials in the decreasing order of the degree. That is, 1 plus x and x plus 1 are equivalent. Only the compiler implementation requires that implementing a polynomial in a list of pairs of coefficients and exponent. So each of these pairs will constitute the structure. So a polynomial will be represented as a list of structures. So you can see an example: 5 into x raised to 4 minus 8 into x cubed plus 2 into x squared plus 4 into x plus 9 is shown in the figure here, which represent a linked list. So you have a starting address and the node which is consisting of a pointer to the coefficient the exponent and the address which is pointing to the next node. So similarly, each and every node is pointing to the other node. Address is pointing to the other node. So the last node doesn't have an address. So just a simple application of linked list. So we can also perform addition of polynomials, where you can recurve polynomials, add them, display the resultant polynomial. So how do you add two polynomials? To add two polynomials, we need to scan them once. If we find the terms with the same exponent and the two polynomials, then we add the coefficients. Otherwise, we just copy the term with larger exponent into the sum and just go on. When we reach the end of one of the polynomial, the remaining part of the other is copied into the sum. This is how the addition of polynomial takes place. So we can also implement a stack using linked list. So we can implement the stack, which is nothing but a first in, first out data structure. So whatever you push first will be popped out on the last. So we can represent the stack as a linked list. So how do you do this? In a stack, push and pop operations are performed at one end called the top. We can perform similar operations at one end of a list using top pointer. So here you can see in the figure, so the top pointer has nothing but the address given as 400, and the start pointer is having address 100. It's pointing to the node with the element 10 and the address which points to the next node. So this is the linked list, that is the stack representation of a linked list. So each and every node pointing out, each and every pointer pointing out to the next node, that is the address of the next node. So we can implement a queue also using linked list. So we can represent a queue as linked list. So as we know, queue is a data structure which is last in, first out. So in a queue, data is deleted from the front end and inserted at the rear end. So we can perform similar operations on the two ends of a list also. So here we use two pointers, front and rear, for a linked queue implementation. So you can just see the figure here. So where you have front having the address is 100 and the rear having the address is 400, and each and every node pointing out the other node using the address. So this is the representation of queue using linked list. So we can also represent a sparse matrix using linked list. So what is a sparse matrix? It is a matrix which has minimum number of non-zero elements and a maximum number of zero elements. So here you can just see the sequential representation of sparse matrix, how it had some problem which can be overcome by using the linked list. So I'm not just going to go in detail about this. I've just listed the matrix here. You can see the matrix, there are minimum number of non-zero elements and the zero elements are maximum. So you can see only one element in each and every row or column. So the structure is something like this. You have a head node, typical node, and the Fij, which is something like the element of a particular matrix. So we can also see how we can represent this particular matrix using a linked list. So you can see the rows and columns just having the head node. This is a typical, the head node has down, head and right. So this is how your linked list is. So each and every node will represent the element in that particular row and column. So the row is 1 and the column is 0. So this is how it's represented. So we can also read a sparse matrix. So assuming each line and the particular matrix. Thank you.